and iodine is heavier. All right, so we know it is our halogen is bromine. All right, so if you pass chlorine through X, right, what we are doing, all right, so I'm answering this part of the question. They say pass chlorine, all right, so we have chlorine reacting it with X, is a halogen. For example, let me give an X reaction. What is basically happening is chlorine, for example, with sodium iodide, right? What is going to happen?
So chlorine will displace iodine.
That is correct. So that means for this equation, all right, let's do it up here. So you'll get sodium chloride plus I2. That means down here, what should we get? What? What should we?
MCl.
MCl
MCl
plus X.
plus X.
Right, MCl plus not just X, it has to be X what? X2.
X2.
Right, because remember it is representing a halogen. And the halogens are diatomic. And since as it is bromine, is the color of bromine.
Red brown.
Red brown.
Red brown.
Right. So since X is bromine, we expect what color again? We expect red brown.
Red brown.
Red brown color.
Right. All right. So I would say a red brown. Any area you want to put it, all right, but I'm just writing a red brown color will be produced. If you want to say this solution will turn red brown, however you want to say it. All right, for this one now, so we know we are testing again for the bromide ion, which is a halogen. So if we add silver, and once we use silver and nitrate, we are testing for the halogens. So we need the table, well, it did not, it gave us 2 marks. So we're going to need an observation for silver nitrate, and we're going to need an observation for concentrated ammonia. So when we add silver nitrate, if bromide ion is present, does anyone know what we should observe?
Cream color.
All right. We're going to get a, we're going to actually get a precipitate, so put cream precipitate. Cream precipitate will form. Now, when we add the concentrated ammonia, what will happen?
The cream precipitate would dissolve in concentrated ammonia.
That is correct.
Sir, if I said the color of the precipitate was white, then would I mark me down for that?
Yeah, because the white precipitate would indicate X is chlorine. So chloride ion, when it forms the precipitate of silver chloride, that is white. The bromine is cream, and the iodide will give you a pale yellow color. All right, so the color makes a, yeah, it's important to put it. So white is for chloride ion, cream is for iodide, and the yellow is for the iodide ion. Now, does anyone know what will happen or which reaction is taking place with this sulfuric acid when we react it?
So now first form sodium hydrogen something, then I get so
And
that
So is the displacement reaction?
so with this one, when you react them with sulfuric acid, so when you react salt with bromide ion, two types of reaction occur. But so two reactions occur. But in the second reaction, so in the first one, you will get hydrogen bromide. And then the second reaction, the first, this MX going to react with the sulfuric acid. As the person said, you would get the NaHSO4 and HBr. Then the HBr now is going to react again with sulfuric acid, and you get sulfur dioxide and Br2. Reddish brown liquid, the
so you can write down now,
is
please.
pungent gas.
Sir, this table is about aqueous and solid halides.
Say that again. If it's with what?
If this table is based on aqueous halides and solid halides.
It's a mix. This is like a kind of like qualitative, but it's specific to halogen. All right. So you see this one here. It's so let me switch ink. So this one, it's about this is redox reactions. All right. Let me not redox slash displacement. All right. So column 3, it is displacement. This one here is qualitative analysis. Qualitative analysis. All right. And this one is a specific reaction of the halogens with sulfuric acid. All right. So MX, so we would have gotten, all right, let me clear off the question from up here. So we are going to get two gas, right? Got the question already. All right, so let me give you a typical example, and then you can switch it out with MX. So sodium bromide, with sulfuric acid, get sodium hydrogen sulfate, and it would be HBr. Then the HBr reacts with sulfuric acid, and that will give you sulfur dioxide, Br2, and water. I'm going to post a section of in the study guide. I'm just going to screenshot that part and post it in the community section. All right, but basically, right, so when you react MX, so MX is basically just like sodium bromide. I'm going to put Na is like MX. So MX is like sodium bromide. That means we are going to get SO2 and Br2. What do we know about SO2 in terms of what would
It's a
be
choking gas.
all right. The descriptor choking acidic gas, right?
said it is also pungent, right?
We normally use pungent with ammonia. The description I see for it is choking acidic. Normally see pungent for ammonia. Let me
So what
scroll
about the
down
color?
again.
Must mention the color.
It's colorless. It's NO2 as a color. So we are going to do transition and qualitative. So we will look at the colors. So we will get a choking acidic gas produced. Sorry, something is in the way. Right, so we'll get a choking acidic gas being produced. And then bromine, what is the color of it again for bromine?
Red brown.
Right.
Sir, could the choking acidic gas observation be used for all halogens?
No, man, the choking acidic gas is for SO2. Let me just make that. So this is for SO2, and this right here is for Br2. Because if you look at the reaction here, you are going to get SO2 and Br2. Wait, give me.
Sir.
Oh, I understand what you're asking. So for this reaction here, chlorine. All right, so let me just finish this and make a note on the board, because not all of them will actually do it.
Sir, question. How you know that MX was on sodium bromide, sir?
So the reason why they put MX, right, is that from the notes, right, when you react a salt with halide salt with sulfuric acid, this is the reaction, the specific one for bromide. You get hydrogen bromide in the first part of the reaction, and in the second part, the HBr reacts with sulfuric acid, give SO2, Br2, and water. There's two reactions that actually this is the first one and this is the second one. So because we know that X is bromine, that is why we know that these two products would be produced. Understand?
So I understand that part, but I don't understand how we get it to be sodium bromide.
Oh no, man, I'm just giving an example, you know. I'm not saying MX is sodium bromide, you know. I'm just giving an example that says, right? So I'm saying, for example, if MX is sodium bromide, so I'm just showing an example of the actual reaction of a halide salt. So this is an actual example. So they are just, remember, X is just a random compound, arbitrary one, MX. I'm saying MX can be sodium bromide, and this is the reaction that would occur. So we know that this is the reaction that occurs, so we are expecting SO2 and Br2. I just use the sodium bromide as a specific example for explanation purposes.